Yes, Katli. I want us to just have a quick discussion about interest in financial mathematics. As you are aware, there are two types of interest, which is simple interest. Yes. And interest, by definition, it's when you borrow money, you are expected to pay an extra charge onto the loan. So that, and this charge is expressed as a rate, as a percentage rate. So under simple interest, if the question wants you to calculate the interest end, not the amount, the total amount you're going to pay, you stick to this formula. That simple interest, the simple interest is going to be the principal, that's the amount that you have borrowed, times the rate, times the time in years, divided by 100. So this formula here is used to calculate the end interest. Now, coming here, so if we now consider the total amount that you're supposed to pay back, including the interest and its simple interest, this is the formula that you use. It's the principal, the amount that you are going to be paying in total is equal to the principal, that's what you borrowed, brackets 1 plus I times n. Now, I, it's the rate expressed as a percentage. For example, if you are to say it's 4.5%, then you're going to have your I in 4.5% is basically this divided by 100. So it's your I becomes 0.045. This divided by 100. This is what this I stands for. So that going to the first question, 4.1.1, you were to calculate the simple interest end when the rate is 4.5% up to 10 years. So the simple that you're going to be charged is going to, according to our formula here, it is going to be 1,000. That's what borrowed times the interest rate times 7 all over 100, and it gives you the correct answer there. It's supposed to be 5,670. Yes, that's the correct answer for the first one. Then, looking at the second question, the second question here speaks about inflation. And inflation is a compounded quantity. What do we mean by a compounded quantity? Now, that is the type of quantity where you generate when amounts for compound interest are generated from previous earnings. So compounding is going to be adding interest on top of the other. And under that, the amount that you're going to eventually pay, if it's compounded interest, if you start with the principle of P, it is going to be P brackets 1. Now, the rate here, I, it means that if it's 4.5%, you're going to be doing what? It's going to be 0.045, like I said. Yes. Now, Going to the question, it says that Miss Gray wants to buy a television set that costs 27,660,000 now. If the average rate of inflation over the last 5 years was 6.7%, calculate the cost of the television set 5 years ago. So what we know here is the present value. And in our formula, we are going to put our present value as the 27,660. So what we are interested in here is the cost, the principal, the original amount 5 years ago. So it is going to be our principal 5 years ago. This is the amount now. This is the amount 5 years back. And the rate, by the way, the rate was 6.7%. How do you express I? You divide the 6.7 by 100, it will be over 0.067. Then it's added to 1 there. Then n is the number of years, which is 5. The n here is the number of years, which is 5. So when I do that, I get that 27,660 is equals to the principal, that's what we're looking for, times 1.067 to the power 5. Then what I'm going to do next is to divide throughout by this. We are looking for that. That's the unknown. So we are going to divide both sides by 1.067 raised to the power 5, both sides. Meaning that our P is going to be 27,660 divided by the 1.067 to the power 5. And it gives you 20,000 as your answer. It gives you 20,000 as your answer. Then 4.1.3, at what rate of simple interest should Miss Gray have invested her money 7 years ago if she intends buying the television set now, using only her original investment of 18,000 and the interest over the last year, the last 7 years? Now, the interest here is simple interest. We said the amount for simple interest is given by this formula here, where P is the original amount times 1 plus I, expressed as a decimal, times the number of years. And that's exactly what I've done here. We are using this amount, this formula for the amount end under simple interest. So when I substitute the given values there, now the television costs, the investment there is 27,660. She started off investing 18,000. Then plus 1 times, we are interested in finding the interest rate over 7 years. So if we are to solve that, I am going to start off by dividing 18,000 both sides to give me that fraction there. 27,660,000 divided by 18,000 equals, then you are going to be left with this on the right hand side. Okay, then if you are to do that, then the next thing is this one here has to be subtracted both sides, so that you're going to have this ratio here that you got from there all minus 1 is equals to, then you'll be left with 7i. You'll be left with 7i. Meaning that now your I, that's what you're interested in, is going to be whatever you get here divided by 7. And it gives you I as 0.076666. Remember, this is the rate as a decimal. If you are to convert it to a percentage, you'll have to multiply it by 100. So it's going to be 0.0766 times 100, and the rate becomes 7.67 to 2 decimal places percent. Yes. Then the last question is about exchange rate there. 4.2. You're given that $1 is equivalent to 12 rands 91. 1 pound is it's 16.52 rands. But now we want to find the exchange rate between the dollar and the pound. From here, I can work out what 16 rands 52 is worth in terms of dollars. Ghana 16 rands 52, it's only 1 pound. So if I could know what 1 pound is in terms of dollars, I would have solved the problem. So then I go, okay, $1 to 1291 rands. Then what about the 1652? How many dollars is that? Cross multiply to solve the ratio. Then you'll get X as 16.52 divided by 12.91, giving you 1.28 dollars, which is equivalent to 1652 rands. The 1652 rands, 16.52 rands is 1 pound. So what it means there is that 1 pound is equals to 1.28 dollars. Yes, that's the end of the question. Thank you.